Okay, this is problem 14-8 in our Hibbler text, and I'm going to read you the problem. We've got a force that's 250 newtons being pulled down on the pulley right here. So we're going to use this, and we're going to use subscripts P to represent our pulley, and we're going to have a 250 Newton force pulling down. And this is going to mean that this block is going to go up. So if I pull this down, this block is going to go up. And I want you to recall the dependent motion type problems that we had done earlier. So if I pull this down, we know that this is going to go up. I'm going to have to deal with some data related to the problem. So I'm going to redraw my free body diagram on this pulley system, excuse me. And we know that I'm going to have the change on the side with the pulley, and I'm going to have the change on the side with the weight. And so the whole length of my rope is going to be L is the segment associated with the weight, and the segment, 2 times the segment associated with the pulley. So we've got those 2 segments there. I've included my force. And the other thing is that we know that overall, the change in the rope is not going to change. So I'm going to look at the change of this is going to be related to 2 times the change in my pulley side. And so we've got that force of 250 newtons that's being applied. And we want to determine the speed if the 10 kilogram block has moved, when it has moved 1.5 meters from its resting point. So we've been told that we're going to go up 1.5 meters here. And so in order to do that, I'm going to have to utilize this equation here. So if I put 1.5 meters, that's going to go on this side. It's going to be a negative 1.5 meters because it's going to go in the other direction. And I can solve for my change in SP, which is going to end up being 0.75 meters. And we can utilize this negative if we say that this is positive, and we can utilize that negative, but we know that our change in our pulley here on this side is going to be 0.75 meters. Using our conservation of energy theorem, the work that's done by the force associated with the pulley side is minus the work that's dealt with that left out is going to equal our change in kinetic energy. So we've got the weight, we've got the pulley, we've got our change in kinetic energy. We could apply the force times my change in distance, which is 0.75. That's going to give me my 187.5 joules. We know what the weight is and how much the weight of our system moved. It's 1.5 meters, 9.81 meters per second squared, and the mass of 10 meters. And we find that that is the joules associated with how we're going to change in our potential energy. So I'm going to have my 187.5 minus my 147.5. We know that 1/2, 10, because this is 10 kilograms, is 5, and that's V squared. And we're going to find that as I'm pulling that down with a force of 250 newtons, that the weight, when it reaches 1.5 meters, is going to be traveling with a velocity in the upward direction of 2.84 meters per second.